Hi, I'm Adam Swaab. I'm a CG artist. I've been working in films and commercials and various other media for quite a while, and I've been using Houdini for a very long time. You might know me from the Houdini 18.5 splash screen, which was a joy to produce. And I'm here now to talk to you about XPU, the XPU Karma render engine, brand new in Houdini 19. So come along. We are going to take a look at one of the most exciting features in Houdini 19, at least from my perspective. And it's something that I've been waiting for, and I think a lot of people have been waiting for at least 4, maybe 5 years. And it's finally here, and that is XPU rendering for Karma. I want to be pretty clear, and those of us who are in the beta forum, I think, have a pretty good understanding of this, but this is going to be qualified as a tech preview. That means it works, but there's still a lot of areas that are under development, and it's not 100% production ready at this point, but I think it's in such a good place, and it's been incredibly exciting to use, and I'm just thrilled to be able to talk about it and share everything that I know about XPU, or at least as much as I can tell you in 30 or 40 minutes in this presentation here. So we're going to dive in. What you see here are 2 test rendered sequences that I did of the same animation, and they're both using XPU as the render engine here. The first one that we're looking at is this kind of metallic liquid and a lot of diffuse surfaces and stuff like that. There's some metallics in here and plastic looking things. And the render time on this on my machine was, I think, about 1.5 minutes a frame. You can see that there's pretty heavy depth of field. It's not completely without grain, by the way, but it's pretty good. Obviously, I could have eaten a little bit more render time and cleaned it up a bit, but for presentation purposes, I thought it was pretty good. I think with some post denoising, this could be totally acceptable as a final image here. I do want to talk a little bit about my machine and my render specs, just so that there's an apples to apples comparison here. I have a 2 GPU setup with 2 NVIDIA 2080 cards, and I have a Threadripper with 16 cores. Just so you know, XPU is going to use all 3 of those together, and that's kind of what it does, is it uses the GPUs and then uses CPU at the same time. And you'll see that when I start rendering. I'm going to show you the next sequence here as well, which is the same animation. But you can see that we're using different materials. We have normal maps working for the textures. Displacement is working. I don't think that it was enabled at the time that I did this test, which is why I went with normal maps. And also displacement does come with a bit more render time overhead in it. So I was after something fast and something that we can show here in demo as well. But the thing to notice here is glass and refractives and all of that other stuff. So typically in the past, a full frame of glass like this rendered out of Mantra would have had me running for the hills, because I know to get it clean, it would have been minimum 30 minutes a frame and most likely upwards of an hour, even more than that, to get a nice clean frame. I want to tell you the render time for this. This was 2.5 minutes per frame to get a nice clean render here, and it's looking beautiful. The render that we're seeing here did go through a tiny bit of post denoising on here, just to make sure that everybody knows exactly what's happened to the image. And mostly that was to clean up some issues with caustics that were happening in the reflected passes here, not so much to clean up the refractions. But overall, very, very happy with the performance of XPU so far. So why don't we take a look at a scene, and we'll take a look at this scene in particular and play around and take a look at what XPU is and the material system as well that was used in putting these tests together. So here we are in Houdini, and I'm parked on a frame. I've disabled the, here it is here, the liquid chain over here. I can turn it on if we want. I've disabled it just because we don't really need to see this to do our testing. It's going to slow us down a little bit. And we'll just focus on these objects so that we can actually see everything here. Now, why don't we go ahead and do a quick standard Karma render of this. So Karma's going. It already had my geo loaded in, and we can watch the little render count here. Might be a little tough to see over white, but we'll keep an eye here on the final render time. And keep in mind, my pixel samples for the viewport are down pretty low at 9. That's a very low setting. So we're coming up in a finished frame in roughly 21 seconds. Okay, now we're going to go ahead and switch here from CPU to XPU. And just remember, keep in mind, we were at 21 seconds before. XPU, initializing, you can see grabbing both my GPUs, and oh, we're done. So that was 2 seconds. It was very, very fast. Now, if I want to clean this image up, I could go ahead and give us a lot more pixel samples. Why don't we say something like 120 pixel samples? And again, you can see all my GPUs are working. We've got CPU working here. We're rendering. We were at 21 seconds, by the way, for a noisy image out of the Karma CPU. And we're going to close in on about 15 seconds for a much, much cleaner image here out of XPU. So that is absolutely amazing. One thing you'll notice is that the two renders look very, very close together, which is important as well. I'm going to go ahead and go back to our pixel samples here. We'll just keep it low just for testing and being able to spin around. I just want you to see the performance here. So I can move in and out, and you can see that we are getting resolved images very, very quickly. It's pretty amazing how fast this is all working. And in case you're wondering if it's only happening this fast because I have this particular frame cached in, memory or something, why don't we go to some random frame in here, like frame 300, and there'll be a small update. You can see here just as it's loading the geo in, which has nothing to do with XPU, and we've rendered our frame in 1 second. So very, very fast. I do want to point out that some of the inefficiencies here in terms of that little wait here is because I'm reading live in from SOPs with a SOP import. I've done nothing here to bake my stuff appropriately out to USD correctly. It is a totally unoptimized workflow in terms of working in Solaris and LOPS in USD. So there's a lot of overhead that's just coming from the conversion from SOPs back into LOPS, which, again, baking all this stuff out would totally remove the need to do all that stuff. So it's very, very exciting. And you have all the same things that you would be used to as well. So depth of field, motion blur, all that other stuff. I'm going to select my demo here. And this time, instead of using our viewport, we're going to go ahead and use our render settings here from the demo. And I'm going to look through my camera that's here. And you can see I have depth of field enabled. I'm going to go ahead and take my camera and we'll just play around with like super low depth of field, just so you can see how well this actually is responding here. And let me just turn off my lock, make sure nothing is selected. Let's keep my geo on, please. Full geometry. All right. And we can go very, very low, again, with our f-stop. So you can see it is incredibly responsive. Why don't we go ahead and lock our camera and we can spin around in real time. We can go get very close to something. We'll find a nice detail here. Maybe go over to frame 462 or something like that. So there we've got some detail here, and we'll just go ahead and find that camera. Make sure we're actually setting our focal point to something that we actually want to be in focus. And you can see how fast that is. Pretty amazing. So I wanted to talk a little bit about the material system, and we'll do that in just a second here. All right, I have switched back just to my viewport settings here because I've disabled depth of field in the viewport, and I'm still working with a live camera, but maybe we'll back out of that. Let's make sure we're not selecting our camera anymore. All right, so we have a pretty in focus image here. And what I wanted to show is the material system that we're using here. So we can close out of this, or maybe we'll keep it open if we want to just adjust our pixel samples, but I'll kind of dock it down near the bottom there. So going into our material library here, we have something very exciting in here. We have MaterialX. And MaterialX is an interchange material system, which means that it should be readable by any application that can read MaterialX materials. So that's brand new to Houdini and Houdini 19. And it is a very, very good material set. It's very full featured, and it's continuing to be fleshed out in Houdini. There's still a couple things that are not enabled under the hood just yet, or have been enabled for beta, but not enabled for the final distribution of Houdini 19, because I know there's some things that are still being worked out. But just to give you an idea of what's here, if you go to MaterialX, you'll see there are a ton of different things here. If you go to the PBR section here, you have all these different kinds of materials you can use. I'm using the standard surface for most of the stuff here. I want to point out with MaterialX, by the way, that XPU currently is only supporting a couple different material PBRs, little base materials, whatever we want to call these. The standard surface is going to be the one that appears to be the material to go for with MaterialX and XPU. So anything that you're building, I would say you want to start off with the MaterialX standard surface as your base material here. The other ones that are working with MaterialX, or excuse me, with XPU, at least at the time of this recording, would be the standard principal shader here and the USD preview surface shader here. My understanding, by the way, is that if you use a principled shader under the hood, it actually bakes it down into a USD preview surface. So you're almost better off forgetting that. And if you want actually something that has some functionality to it, you're better off going with MaterialX. USD preview surface is very, very limited and really only works with USD nodes, which if you do a search for USD, you don't have a lot to work with here. USD preview surface is basically just read in a texture and apply it, and that's about it. Can't do a whole lot more with it. So you're going to want to use MaterialX standard for most of your things. There is a MaterialX USD, by the way, which does work. Let me see if I can find that here for you. Go back into MaterialX, and it should be PBR, and there it is. There's a MaterialX USD preview surface. So if you did want something analogous to USD preview surface, that would be it. So the standard surface is pretty much what you would be used to here. Base layer, specular transmission, subsurface. Subsurface, by the way, at the point of time of this recording isn't completely working in XPU. It's working in CPU, but XPU, I think they've still got some work to do. So I'd forget about this for now, but it should be in there at some point. And then everything else here seems to be working. So very, very good. I wanted to show a couple different things in here. So obviously we can take in textures and we can apply them, etc. But what else can we do? Well, we can do procedurals. So let me go ahead and apply this. I'm going to go back up to my stage, and I'm going to go into my assignment layer here. And instead of the cloth, I'm going to go grab a procedural. Now, this isn't a material to write home about, but the point is to show that procedurals are supported in here, and you saw how fast that was. So what did we do? What is this procedural that's applied here? It is a three-dimensional fractal here, and I can dial the octaves down. Right, you can take a look at how that's all working. Pretty standard, right? What are we doing and how are we making this work? Well, we have everything that you would need. You have a prim variable reader. Right now we're reading our rest attribute, and that's to make sure that the noise has a coordinate system that it can stick to. So as these objects are moving around, we're reading rest. We have stuff here for adjusting the coordinate space. So this is just multiplying our rest position. So I'm scaling it down, which actually makes it larger. Or a smaller number is actually going to scale this pattern up. You'll see if I bring that up, the pattern starts to shrink. If I bring it down, the pattern's going to get bigger. Right, so typical ways of adjusting materials procedurally. This is our fractal. Here I'm remapping our range because the fractal outputs a range from -1 to +1. So I'm just kind of adjusting the contrast here. You can see how that works. So a lot of the things that you're looking for out of procedural texturing here. And then I'm plugging that right into a mix and just mixing between two colors. That's going into our base color. At the time of this recording, and it apparently isn't going to be ready in time for Houdini 19 release, but there currently is no color ramp node yet for MaterialX. So that should be forthcoming because I know that it is an absolute requirement for doing procedural texturing and making sure you've got interesting colors and stuff like that. But you can see that the procedural is working and it's working great. If you go down to your MaterialX stuff in here, you'll see you have a whole lot of procedurals. You've got ramps, you've got different kinds of noises. Again, more noises, and then you've got triplanar projection as well, which I know is important to a lot of people. Honestly, this is going to be something that is really worth exploring and taking a look at. I haven't looked at any of the other PBR stuff that's in here. There's just so much stuff and there's so much to go through. But the results kind of speak for themselves. They look amazing. So I'm not sure there's much else to talk about with procedurals, but I do want to kind of go back up here and turn on my liquid. And now I've turned off the glass material that's on here. And I just put a kind of standard material there. The reason is I wanted to go in here and just play around with a kind of base material just to show you what's available to us. So I'm going to turn this down to maybe like a dark gray. I want to show you what happened so far with subsurface, which again isn't really implemented yet, so don't trust this. Something happens, but you can see it's not right. Even if we start adjusting the scale, it's just not working at the moment, but that should be implemented at some point. But all the other stuff that you'd expect is here. So if I wanted to make a gold material, we can start with some kind of dull gold color here, and then we can change our metallic all the way metallic, and then adjust the specular as necessary. You want super shiny gold, go that way. You want something that's more like a rougher gold, go that way. Right, everything that you need is here, and you can see that it's incredibly responsive. It looks great. I'm going to go and load our liquid up here. So I'm going to assign my material and wrong chain right here. And let's go ahead and grab our liquid. So this is the standard liquid here, and it doesn't look great yet. There's some other stuff coming. We got to play with it in beta for faux caustics, but it's still being worked on, and it was removed for 19 for the actual release. And that should help with the look of this quite a bit. Also keep in mind my settings here are pretty low in terms of the XPU, the refraction limit. It's only set to 4. I'm going to go ahead and switch back to my Karma one. Let's go ahead and change that to the demo render settings. Excuse me, that one right here. And I'm going to need to disable depth of field in here as well. Let's just turn off depth of field and motion blur. So this will end up looking a little bit better. What I wanted to show is that for my render, I did enable the Caustics button here, which is under geometry and shading. And maybe we can take a quick snapshot. We'll see if that works or not for us. Take a quick snap. And let's go ahead and turn on Caustics. I don't know if you can notice, but this area here improved significantly. We'll let this kind of go a little bit longer. Oh, right now it's only at 6 because our pixel sample is set to 9. Why don't we set this to something a little better, like 48? And even at 48, this should really only take about, I don't know, 15 seconds, apparently. We'll see, maybe 20 seconds. All right, 15 seconds. Not looking too bad. So we'll take a snapshot of that. And let's see if we can actually take a quick look here. So no caustics, caustics enabled. So you can see big difference. This is looking a lot better. So a lot of really good options. Things are working very well so far in XPU, but just keep in mind, it's not production ready yet. You can definitely do a lot of stuff with it. It's not going to handle everything that you need. It really depends. If you're banging out some motion graphics, stuff like this, you'll most likely be in a pretty good place, but it's important to know what's not currently supported in there. Now, probably the question you're asking next is, what about volumes? Are volumes supported? Well, let's go ahead and take a look at a file with volumes in it. What we're looking at here is a pyro simulation. It's just one of the explosion presets that come already with Houdini. I did very, very little to this, just baked out a little bit of the animation. And what we're seeing in the viewport is lower resolution than what we'll actually render. You can see our actual volume resolution written down here. This looks quite a bit lower, and that's probably because I've got it capped to 400. And I'm going to just quickly do a render here. I want to let you know that I've turned off the emission in our render before we start. So let me go to render, and we will render with Karma and our viewport settings. I want to make sure I'm on XPU. And let's go ahead and start our render. It had something cached in there, by the way, previously. So give it a second while it actually starts up. Let's move around and see. There we go. So our render time for that is 3 seconds, and it looks really good. You can see the image resolving very quickly. Let's go ahead and dive into our material library and take a look at what's here. So the thing that is actually rendering this volume here is a new material called the Karma Pyro Preview material, and it's meant to work just with XPU here, I believe. It should work with CPU, but maybe not. I don't know. Let's take a quick look and see if it does. There we go. All right, but we don't want CPU. We want XPU for this test. So it's incredibly responsive. Note that I can bump our density up, go very, very low, and still get our image resolving incredibly quickly. You want to change your smoke color, almost instantaneous. It's not having to reload any of the volume back in. It's just there already in memory. And the changes are happening so fast. It's really brilliant. You have absorption working in here. You can see as I bring it one way, we're getting different absorption happening in here. Everything that you need. Scattering is in here. Make it a little more absorbing. There we go. So looking great. Now I'm going to go to scatter, and this time I'm going to delete that. And boom, we've got a fireball here, which we can immediately turn around. So notice scatter is just giving us intensity and nothing else. And that's because scatter is actually a color value, and that's coming in from the pyro look. It's actually baked in. This color information is baked in. And it reads two things. It reads the intensity, and then it reads a mask in there as well. I can turn off our scatter mask. And so it's no longer masked by that mask field, but obviously now it's too bright. So you can bring that down. And all of a sudden you've got a completely different look to your explosion here, right? But typically you want that with a mask and something like that. And you can always go ahead and add your additional fire if you so choose. And then here you actually do have control for your fire. And of course you can use that same mask if you want and play around with the look, get something completely different and gnarly. Even go for something, totally wacky and wild if you wanted to. But let's keep this just like that. And why don't we just adjust this value a little bit. I don't know. We'll probably get rid of that. Pretty cool though. Yeah, that's looking amazing. So let me jump back out here and kind of show you just how quickly this thing is working here with lighting and everything else. So I've got an HDRI in here, just a dome light, and you can see that we're getting almost instantaneous updates here. Can disable our dome light, and I have another distant light that's put in, right? Put them both together. Got an amazing looking little fireball going on here. And just to show you how fast this is, I'm going to step through some of the animation here. And you can see even the frames that weren't cached, at least cached within LOPS here, loads it in fairly quickly and then starts rendering. So volume support looking very good. The one thing that isn't supported currently, but it is on the roadmap, is motion blur for volumes. So that should be coming at some point, but I don't think that's ready for the Houdini 19 release. So I realize a lot of people don't know how to get any of their things into LOPS in render. So I thought we'd take a look at just a really quick basic example here. What we're going to do is just make some random boxes with different colors and a backdrop. We'll bring it into Solaris and render it out. So here's a geometry. We'll call this boxes. And we're going to go inside. I'm just going to make a line in the X direction here. Give it a length of 5 and set the origin to negative 2.5 so that it's centered. And then we'll give it 30 points. So we got a nice little line. We can delete everything except the points. So I'm just going to take that out and choose keep the points. And now we'll randomize the positions there. So we'll use an attribute randomize, change that to P. Instead of setting, we'll add between -1 and +1, and then we can play with the scale as necessary. All right, so we've got a decent distribution, and maybe we'll just change Z to space that out a little bit more in Z. Okay, now we'll copy some boxes. So take a box, make sure it has normals, and we'll copy to points. All right, that's going to work well for us. We'll attribute randomize again. This time we'll randomize scale. So type P scale in there, dimension of 1, plug that in, and play around with your min and max values. Maybe go and give it a different seed from before. You can play around as necessary. All right, now we'll put some color on these boxes. And by the way, in my copy to points, I'm going to choose to pack these so that they're all instanced. So now I'm going to type color. Oops, wrong one. that would work, but I want to do something different. I want to do the attribute adjust color. It's a new node for 19. It has a bunch of awesome options, especially because pattern type, I can just say noise, and it'll map this noise into here. So why don't we choose one of the nice little options that are in here now. Let's try, maybe Twilight looks good. And you'll notice you have some really cool things like element size you can play with, offset. It's pretty awesome. All right, so we'll say something like that is going to look good for us. Now I want to make sure that we have name attributes, because when I middle click here, we don't have any name attribute on here. I'm going to quickly do this within assemble SOP. And that's going to create names for us, and we don't need to pack it because we already are working with packgeo. So now when I click there, I see we have name. Go to null, and we'll call this to LOPS. All right, now we'll make a backdrop. So I'm going to start again with another geo. We'll call this BG for background. Start by making a box. We'll make it 20 by 10 by 10. Copy that, paste in here, and multiply that by 0.5. So that's always going to be on the ground. Now we'll zoom out a bit, go into primitive mode, delete that out, go to edges, select, polybevel it, divisions all the way up, and distance will do something like that. So we've got a nice rounded backdrop there. All right, I see our normals are going to point the wrong way here, so we'll reverse that. And then put a normal SOP down, a null, to LOPS. All right, we're ready with our geo prep. Now we'll bring all this stuff into LOPS. All right, now we're ready to bring this into LOPS. So we're going to go to our stage context, and I'm going to grab a SOP import here. I also want to make sure to change my build to Solaris. And for the SOP path, we'll go ahead and grab our boxes and grab to LOPS. That brings our boxes in. We see that they are coming in automatically here as one piece here for a prototype. So they're being instanced correctly. And we have all the individual pieces here if we wanted to texture them individually. But we could also just apply the texture right there. Now note, this path here is SOP import 1 coming from the name here. And we have everything in here. It might not be as organized as we want, so I'm going to make a little structure here. So I'm going to call this boxes geo, and in here we'll call this boxes asset /OS. So we have boxes asset. Inside there we have boxes geo, and then we've got all of our information. The reason I'm doing boxes asset like this is we're going to want our materials to be grouped under here as well. So let's go ahead and make a material system here. We're going to use a material library. I'm going to put it right under here. Dive inside, and we'll make a material. I'm going to go to MaterialX, and I'm going to go grab a PBR standard surface, and we'll call this boxes. I'm going to leave everything here, but we do want to be able to read in the point color. And for that, we're going to need a USD prim variable reader. Changing this to a vector 3, and we'll want to read display color and feed that right into base color here. So CD gets converted into display color when you're in LOPS. If you check your boxes here and you select one of your pieces and look at your scene graph details view here, you should be able to see a prim variables called display color, and you can see that there are values in here for all of the pieces, and that's how you know what to use here. All right, so that's the material, but it's not applied and it's not grouped in the right location. If I collapse that, we can see that the materials are not sitting inside our box asset. So all I'm going to do is prepend this. So boxes, asset, /materials, and now they're living inside there, but we haven't applied the material yet. So we'll do a material assign, or assign material. Put that right here. And for the primitive, I can put it on all the pieces. I can do string matching, pattern matching, or I can just apply it onto the prototype here, which is what I'm going to do. I'm going to grab the piece. I'm going to put that right in here. And then for the material, I'm going to assign my box's material. We can run a quick render test just to make sure this is all working. So I will change to Karma, and we can see that that's working. Now, if I go and go to the XPU engine, what you're going to see is that the color information isn't being read in. Currently, that's not working yet in XPU. I hope that will be incorporated soon, but at the moment, it's only working in CPU. All right, so we've got that sorted. I'm going to just change to GL view so I can work quickly. And now we'll bring in our backdrop the same way. So we'll do a SOP import. And I'm going to call this background geo. And that's going to go into our background asset, material library. And here, again, we will go find our standard surface. This time, we're going to take the specular and we're going to turn that all the way down. We can turn roughness all the way up, but it shouldn't matter if we're at 0 for specular. And make sure we give this the name background. And of course, that needs to go into our background asset path as well. So when I'm selecting there, I should be able to see background asset and make sure my material is here. I don't think that I actually referenced my geo, so let's go ahead and do that. I'm going to go grab our background to LOPS. There we go. All right, so now we have our asset, geo, and materials all together. Let's assign them. So primitives, I'm going to want to grab my background geo, and I would like to assign my background to that. We can merge these together into one stream. And now we're going to want to place that. So we just need to do a transform right down here. And I do want to say which primitives I want to transform. I would like to grab my box's geo. I can turn on wireframe, should help a little bit. All right, so we've moved that where we need it to go. We have our materials. Now we need lights and a camera. So I like to do this kind of merge thing. If we're just working for ourselves and we're not really part of a real USD authoring pipeline, it's probably fine to just work like this without going into all the sub-layering and correctly authoring all the USD stuff. We just want to get a render out here. So we don't need to go through a massive process. All right, so I'm going to use a dome light. And I'll plug that right in. And I need to grab a texture, so I will go into my personal texture library, grab an HDRI, and we'll go grab this abandoned hull. I have ACES configurations ready to go for that. We can see we've got a little bit of a background in here now. And now we need a camera. So I'll put another merge down here. And I'm just going to create a camera. By default, that's down here. I don't want that. I'm going to separate that, put it like so. And we're looking through our camera. Let's go ahead and find a view that is going to work for us. About something like that. And then we'll put down a Karma node here for rendering. So we can look through this if we want. We can up our pixel samples to something that's going to work, whatever feels right. And let's go ahead and launch a Karma render. And now we have our render ready to go. So there's a little bit of hoops and stuff to jump through to get it going, but once you've got your render pipeline all sorted, you can do all kinds of fun stuff. And when they get the XPU stuff working with the point colors, by the way, let me make sure I'm going to my actual render settings here. So when they get the XPU stuff working, the point colors should be just fine and come through here correctly. But for now, if you want to render CPU, you can render CPU. I think the main gist of this little lesson here was showing you how do you actually get your stuff into LOPS and render it out in here in a very quick, easy to follow instruction here. Thank you for listening to my presentation for Houdini Hive. I think you'll find that Karma XPU is one of the most exciting new features in Houdini 19. There are many great features. Of course, I'm partial to rendering, so I certainly love this, and I think you will too. Thank you.